Hey, everybody, this is Tony Miracker. I'm your chair for the Toronto section, and welcome to our February meeting. We have a great evening in store for everyone. Let me just change to the next slide here. Just cloudfirst.io is our sponsor tonight, and we are very grateful that they are joining us. Do stay to the end of the meeting because there are some more information I will give to you as to cloudfirst.io and their involvement with this meeting tonight. Tonight we have three co-organizers, Nadia Aftab, Richard Gunberg, and Jeff Vella. All three will be participating in this meeting tonight. Richard will be the moderator this evening. Jeff will manage, and Richard will manage the question box. There is a Q&A section. There's a tab for you to enter in your questions. We will be answering some questions after each presentation, but there will be a longer Q&A section after all of the presenters have presented. It'll be more of a panel kind of discussion. So just to kind of give you a heads up and information here, some analytics from last year. This is our third annual student meeting, and the topic tonight is SMPTE Toronto student meeting, and we've got a various topics from various presenters that will shed some light to our students and also to our membership base as well, to give them some insight as to the various technologies and give some guidance as to, you know, if this is a great field for the students and our members to get involved in. Last year we had 257 people register, 149 were non-student and 108 were students. The actual attendance was 157, 90, and 67 respectively. We had students from Ryerson, Fanshawe, Centennial College, SAIT. We had 6 presenter, and the various topics were SMPTE membership benefits, IP for broadcast, and some of these we are going to repeat tonight, just update, and esports as well. So Rick, if you're online, I'm going to let you jump in here, and these are the list of our great presenters. I'll also ask Troy if he's online to spark up as well, because we'll be coming to you shortly.
I'm here.
Thanks.
Go ahead, Rick.
Hi, everybody. I'm Rick Rumberg. I'm a SMPTE board member, sort of representing the students and trying to get a lot of young people involved in SMPTE. And Tony, I'm sure Troy will be talking a little bit about this, but this organization is there to try and sort of to establish critical technical elements in the film and television industry, of which a number of you, I'm sure, as students are very involved. And the idea behind this special event is really to give you an opportunity to hear from the experts in the field. And I do encourage everybody that's here, all the students that are participating, to ask their questions. This is an opportunity, again, to sort of siphon knowledge from all these experts in all these critical areas of media. So please do take advantage of asking questions of the people during the event. If we don't get to your questions during the speaker's actual presentations, we'll have the opportunity to sort of come back to your questions at the end of the evening, as everybody, hopefully the panelists and guests will still be here. So I'd like to thank all our wonderful presenters today for being here and taking the time out of their schedules. from across Canada and the States to come and give the students some insight into media and the technologies involved. And I'd like to thank the students from all across Ontario and perhaps elsewhere for participating today. So please, again, I do encourage you to all ask questions as they come up. So first up, Tony, if you want to change over, I guess, to the first slide. Troy English, there's Troy. Welcome, Troy. And I'll read you his bio so you'll know a little bit more about him. Troy has been in the broadcast live production industry for 28 years, starting with his first job as a software developer working on production switchers. Since then, he has spent all of his career developing and creating dozens of products for the industry in collaboration with end users all over the world, and has been CTO for Ross for 10 plus years. He's been fortunate enough to work with some of the best engineers in the industry, and in doing so now has a technical Emmy award as well as 9 patents. Along with Jeff Moore at Ross, we created a brand new SMPTE subsection in Ottawa to help share our passion for the industry within the nation's capital. Troy is currently serving on the SMPTE Board of Directors as one of the representatives for Canada. Welcome, Troy. Thanks for being here.
Thanks, appreciate that. So I'm going to share my screen and make sure we get the right one. So you should all see that.
Yep, you're good.
And share computer with sound is on. Okay, perfect. So what I'm going to be talking about today is I'm actually going to give an overview of SMPTE, what it is, with a focus on that for the students. Okay. So the first one is, what is SMPTE? There might be some people here who never even heard of it. So we always pronounce it SMPTE, but it actually stands for the Society of Motion Picture and Television Engineers. So we have the vision statement and mission statements from SMPTE here, and they're good to look at. So enabling the technical framework and global professional community that makes motion picture, television, professional media available for all humanity to enjoy for artistic, educational, and social purposes. So that's quite a big vision, and we're all here to make that happen together. And the mission statement, to drive the quality and evolution of motion pictures, television, and professional media through our global society of technologists, which would be on my side, developers and creatives, by setting industry standards, providing relevant education, and fostering an engaged membership community. So there's a small little video that SMPTE created. I don't know when this is actually from.
Moving pictures were a revolutionary new medium that captured people's imaginations in the early 1900s. But it wasn't accessible to everyone. You had to be able to afford a ticket and live near a theater. Slowly, access began to expand as more theaters were built. How did we make sure they could all play the same movies? SMPTE engineers developed standards to normalize how these emerging technologies were used to produce and play films. By the 1950s, broadcast technologies sent motion pictures straight to people's homes, the birth of television. SMPTE members created the consistency needed to produce and play broadcast signals. The internet brought another revolution in video. Anyone with a computer could suddenly create and watch content online. Accessibility spread further around the world as SMPTE members worked to standardize the way we produce and send media over an IP connection. Today, people in every continent can make and watch media on their phones in the farthest corners of the world. This innovation of the past feeds the innovation of the present and future. Work in on-set virtual production expands the limits of content creation. Blockchain helps with rights management. SMPTE members help make technology play together nicely. What advancements will you be a part of? Join SMPTE and help make media available for all humanity to enjoy for artistic, educational, and social purposes. Sign up at smte.org/join.
All right, so SMPTE has 3 prime activities that we talk about. So the first one is membership, and we'll have some more details on all of these next. The next one is standards, which is where I got my start in SMPTE many years ago when I think I had hair then. And education. So we're going to look at those in a bit more detail. So let's look at membership. So community. So the biggest thing is, if you're interested, especially as a student, in anything to do with media technology, be it film, be it television, be it other ways of doing it, this is the group of people who are the experts in it. So by working with SMPTE and getting involved in it, this is the best way to meet others who share that passion, and also people who've got the expertise. So there's people like myself who've been doing it for quite some time, and there's others who are newer. So it's one of the best reasons to join, frankly, is that one. And again, if you're if you're more on the student side, it's a great way to look at advancing your career. Because once you start looking at which companies are members of SMPTE, you'll find that almost any company that's involved in media is part of SMPTE, and they come to these meetings. This is the chance you get to build those connections, ask those questions, find out what's going on more deeply. So a little bit of a couple of numbers here, just give you an idea of what the society is like. But there's approximately 5,000 individuals and 200 companies as members, and a lot more people who are following it. And is one that's again, for me, because that's the side I look at a lot, is the all the engineering documents that are produced with SMPTE, and we'll look at some of the others, the Motion Imaging Journal, later. Here's a quick little map of where the SMPTE sections around the world are. Obviously, a lot in North America, Canada, United States, but there are sections in all parts of the world, and we're always looking actually at expanding that to become as even more international than we already are. And a little caveat that some of these pictures are from 2019, so if one of those dots is slightly incorrect, I apologize. There's also quite a lot of companies that are part of SMPTE and contribute in lots of different ways. I'd be shocked if you didn't recognize most of the names on this list. But again, when you look at joining SMPTE, working with SMPTE, contributing, talking with others, these are the people that you're working with and talking to. So if these companies interest you, it's another great reason to get involved with society. And for me, standards. So SMPTE is an ISO, International Standards Organization, which means it publishes standards that are officially a standard as opposed to just a bunch of good ideas. And without these, the video that you pass from one computer to another is just a bunch of random data. So this is where we actually agree among ourselves how to actually pass video around, audio around, metadata. And metadata is basically video information that isn't the actual video or audio. Closed captioning is the most obvious example, and there's a lot more data people pass inside the video as well. And this is where I got started, because I was writing software for the company, and I had to actually make the video and audio be the correct thing. So when I started doing this, the SMPTE standards were, frankly, it was the backbone of everything I did back in the day. Some quick examples. Again, there are a lot of these, but ST12, you can tell how old that standard is because of the number, the 12th one. Time. There is nothing worse on this planet than working in time. It sounds like it's easy, and then somebody says, okay, well, my clip started at this time and went to that time. How long was it? And then we start muttering questions about leap seconds and leap years, and do they do daylight savings time or not? And what time of the year did you record it where the daylight savings was on? And God help you if it's actually on a moving vehicle which crosses a date line. But I'll ignore the pain that we go through. And then, of course, the simple things about, how do I actually map video onto the various interfaces, be they SDI, which is how a lot of us pass video around on cables, or obviously nowadays, of course, on IP networks of various kinds. And then file formats, and there's a lot more. But the reality is without these sorts of things, nothing interoperates. It only works within your company, and frankly, in larger companies, not necessarily even between every division without these standards. So a huge thing. Education. SMPTE also puts a lot of effort into teaching and training on all of the technologies and the exciting things going on. So the Motion Imaging Journal is available. And I will say that I wish I had a lot more hours in the day, because whenever you look at the topics in it, every single issue of it has something that's interesting that I wish I had another 6 hours to go read on every time. It's a treasure trove, really, even for those who aren't students. Pick it up and look at the topics. There's quite a lot there. Webcasts, Sony also, SMPTE, it's that S word. SMPTE has lots of webcasts that are given. There's obviously the ones like, what you're in now, but there's also, tech topics, etc. And there's courses available. I just put 3 up from the web. I went to the SMPTE website and picked the first 3 courses as examples. IP media transport, high dynamic range, which is actually a big topic for the last 5 years or so. Basically, can I get very bright and very dark images at the same time in my picture as well? And then ultra high definition, which you normally hear people talk of as 4K instead of UHD, but depends whether you're in television or film for that one. Student membership. So as a student, it's not the most expensive thing. I actually did the calculation on this. I was obsessive because I'm in R&D and you got to be exact. So I actually went to the website, looked at the cost of coffee and donut from Tim's, and then divided it through that $15. If your phone's gonna be really pedantic on me, I admit, I think that $15 might be US dollars, and I did not do the exchange rate conversion. It's also free for the first year, but essentially this is this organization. If you have an interest in the topic, $15 is incredibly economical. You can always afford that, and you get a number of benefits from it. They're up on screen here. I won't bore you by just reading a bunch of things that I know you've already read, but there's quite a lot of reasons to get involved, and the cost as a student, it's really very, very economical. So that's really the quick intro. I didn't want to sit here and give you a very long diatribe on it, but I wanted to give you a quick idea of what SMPTE is about and why you should join it. And to be honest, if you're doing anything in professional media, it doesn't matter, again, whether it's film, television, whatever, these are the people you should be talking to for lots of reasons. Well, that's it. And on to the next awesome speaker.
Thank you, Troy.
Thanks so much, Troy.
Yeah, you bet.
So hopefully all the students that are here realize the power and potential of being SMPTE members, and look forward to seeing you all signing up.
That's it.
So next up, we have Ryan Morris. And Ryan, you're with us, I believe?
Yep.
So Ryan is a systems engineer at Arista Networks, focusing on workflows within the media and entertainment vertical, with a keen interest in SDN, and you'll let people know what SDN is afterwards, right? Multicast and P2P. I know you're going to be talking about that. Morris continues to provide design and deployment strategies for his customers across the globe. Morris graduated from Queen's University in Kingston, Ontario, Canada, with a Bachelor of Applied Science in Electrical Engineering. Thanks so much for being with us again. Ryan,
No
you've
problem.
been with us a number of times. We really appreciate it.
No problem. Thank you. Thanks for having me. I'm just going to share my screen now. Yes. And I'll share that screen. Can everyone see okay and hear me okay?
Yeah, it's good.
Great, thanks. Well, thanks for having me again. Hi, everyone. My name is Ryan Morris. I'm a systems engineer with Arista Networks, and today I'll just be focusing on media over IP. It's a really, really big topic, which obviously I cannot cover in 15 minutes. It'll take months, years to cover everything, but hopefully it's just enough to pique some interest. So I'll be focusing today on broadcast workflows, and let's get started. Pardon me. learning networking can be like learning a lot of different languages. There's a lot of different protocols, some of which I know, some of which I don't, many of which help us in our everyday lives in consuming media in some sort, whether it has to do with, watching Netflix, YouTube, Disney, VOD, live production workflows, play out. Everything right now is, moving towards a networking infrastructure. And today, I'll be focusing on more on-premises broadcast workflows, things that you'd see in a traditional broadcast station, like routers and, just again, in-house production with SMPTE 2110 specific workflows, like Troy mentioned earlier in his intro. But before we get into how it looks in an IP world, this is what it kind of looks like in a legacy video distribution with SDI. You have probably a lot of racks full of jack fields, a ton of coaxial cables as well that carry, one video signal per, and it's unidirectional. A lot of cabling running within your OB truck, within your broadcast facility, running under the floor, on the ceilings, just weighing everything down. And, again, carrying one signal per cable, that seems rather inefficient. And, there has to be a better way. Welcome to today and the future. That is a modular networking switch from Arista that has a buttload of 100 gig connectivity in there. Like, look, that is just, it's just beautiful. And it's carrying an absolute ton, most likely, of video traffic, of control traffic, of, again, uncompressed video, compressed video, whatever, all going through the exact same media fabric, going through the exact same network. You don't need a separate router for HD, a separate router for SD, and then somehow marry them together going through different pieces of equipment. Everything can go through just that one big chassis switch. And we'll get into some of the scaling factors later on. And of course, you can connect these devices and switches, other switches, into this big switch at different speeds. I have a list of different optics, on the right-hand screen there. Some are 100 gig rates, some are 10 gig rates. They're just really, really big, and larger ones are coming out, like 800 gig optics, 1.6 terabit per second optics. Like the sky's the limit. It's just incredible the amount of traffic that can go through just one of these networking switches. But some of you have probably heard about the conversion from baseband, from SDI into IP. What are the benefits? What's the hype there? Why are we focusing so much on this? There are a lot of factors here, and some of them are just, again, like flexibility and, again, scalability. So talking about scalability, as I mentioned before, a lot of the video routers are, have coaxial cabling, which is unidirectional video on there. Okay, but the Ethernet cables, the optical connections I showed on the previous slide, those are all unidirectional. So 100 gigs one way and 100 gigs another way. That's a lot when we're talking about, possibly HD workflows, HD streams of 1.5 gigabits per second each. That's a lot of flows back and forth that you just can't really match, obviously, on a single coaxial cable. Now, talking about flexibility, you have the flexibility of connection speeds. So some devices might be 10 gigs, some might be 25, some might be 100, all on the same fabric. That's easy to do. You can have different types of formats: SD, HD, UHD, compressed, so MPEG or NDI, convert to, Dash or something. If you want to send it up into cloud, you can do all of that all on one switch. And of course, this scalability, again, from a deployment perspective, you see on the right-hand side there, there are different types of topologies. You have a very, very, very flexible topology, options, just depending on your workflow. Maybe it's a more consolidated workflow like an OB truck. Maybe it's a more distributed workflow like a large broadcasting station, where you might use that spine leaf there, the middle graphic. But you have the flexibility depending on your, again, your facility, to deploy today and also, again, scale in the future. Because we know, we don't remove media workflows. We just add more media to our, to what we need to produce for on-air purposes. And the bandwidth, again, just keep growing and growing and growing and growing. So this is part of the hype for why folks are transitioning to an IP workflow. Now, referring to scalability, I'm not an SDI baseband routing expert. I think some of the larger ones are like maybe 1,000 by 1,000 or 1,024 by some. I'm sure someone else on the line could easily correct me, but the scaling factor that we can get on just a 4RU chassis switch, for example, I show it here. We have on some of our cards 48 100 gig connections. So therefore, on a single chassis switch, which is, I think this one is 6 rack units, we can have 192 100 gig connections there. Translate that to some devices that utilize the full 100 gig link, and you can get to over 3,000 by 3,000 3G routed video signals, and easily tens and tens of thousands of audio signals, and tens of thousands of ancillary data like closed captioning signals throughout that entire network. It's just enormous, and it saves on it. There's power savings, there's space savings, there's weight savings if you're on an OB truck. It's a very forward-thinking path. And again, just some of these are just reasons why, again, people are migrating to an IP workflow. Now, there's a lot of design factors that go into it, depending on what your topology is actually going to be. What formats are you going to transport throughout your network? There's a lot that goes into this. There's also a lot of protocols, some of which I just like to give a very, very brief review now. The different mechanisms, the different methods at which a packet can be forwarded throughout the network. There's typically 3. There's broadcast. So one packet gets sent to everybody else in that subnet. So my kid upstairs, my 3-year-old, he screams and yells and yells and yells. Both me and my other son hear it. He's broadcasting his screams out to me, and we cannot stop listening to it. That is broadcast. When I get frustrated and I need to call my wife to help me out with something, I call her up. That is unicast, one-to-one. Now, multicast is where all the magic happens in a broadcasting workflow. Multicast is one-to-one, maybe, or one-to-many. It's where you want to send your signals, assuming that maybe one or maybe many of them, many receivers need to see it at the same time. Now, multicast is extremely useful for live, uncompressed media workflows. And why is that? Well, that's because in unicast, for example, if I have a camera that is translated to a multicast stream, such as gets translated into IP packets, and those IP packets have a identifier on them, so if you will, 239.1.1.1, just as an example. If I want to send one camera that is, say, outputting at 10 gigabits per second to 5 different receivers, if I were to do that in unicast somehow, I would need to output that stream 5 different times. So that's a lot of bandwidth. That's obviously very, very inefficient, and it will probably blow up your network just with the sheer amount of bandwidth if everybody is doing this all the time. Broadcast, not a good option, obviously, because again, that's just uncontrollable. We want control. That's where multicast comes in. Multicast, as I described, is one-to-one or one-to-many, but it only replicates the signals where it kind of needs to. Maybe at like the last hop, for example. You don't need to send the entire signal many times. You only have to send it to a specific, you only have to kind of branch it off at specific points in your network. It's a great topic to cover that takes, more than a few minutes to cover, but it's the fit that we need for uncompressed workflows because it saves on bandwidth considerably. And again, it offers us extreme control. This is what a lot of broadcast systems might look like today. I say might. They will look like this today. You'll have a spine leaf architecture, and hopefully endpoint devices will support, traditional networking protocols, things that we kind of take for granted today, like DNS, for example. So like no one knows the IP address of ESPN.com. We just go into a browser and type ESPN.com. It'd be really good if all of our all of our cameras and receivers, multi-viewers, all those kinds of devices supported the same thing, having a name associated with it for management purposes. And we're getting there. Then also there's DHCP. Can you imagine if you had to, whenever you went to a different, a coffee shop or a different home or a different house or wherever, if you had to manually type in your IP address everywhere you went? Now do that, take that example, and then, try doing that with thousands of endpoint devices in your network. And it causes, can cause a lot of grief just because there's a lot of typing, a lot of room for error. Why not assign all of these IP addresses automatically? And again, that's just using DHCP. It's very common in traditional networking workflows. And that's kind of where we're going with broadcast workflows. We're taking, it's a marriage between broadcast, like traditional broadcast, and networking and, IT centric protocols, things that will make our lives easier and things that will make these systems more plug and play, I suppose. Now, once you have a control system that actually functions in this way, so I want to be able to send a camera to a multicast destination, a multi-viewer, or some type of up-down cross converter, something where I want to send, again, multicast signals through the network. How do I actually do that? Now, there's different ways. There's something called IGMP. IGMP essentially functions by having your receiver device, your multi-viewer, say, I want to request camera 1. But it doesn't actually say I want to request camera 1. It says I want to request 239.1.1.1, for example, some unique identifier that this broadcast controller knows about because it has a database that maps name to multicast IP, and it tells the receiver to send what's called an IGMP join for a specific multicast group. Now, what happens when that receiver, that multi-viewer, doesn't want to look at camera 1 anymore? It wants to look at camera 2. Well, then it'll send an IGMP leave for camera 1, and then an IGMP join for camera 2, for example. Once the network receives these IGMP joins and leaves, it's the magic of IGMP and other multicast protocols, such as PIM sparse mode or IGMP snooping, that will route the signals from the senders to the multiple receivers if necessary. These are used a lot in SMPTE 2110 workflows, these types of multicast protocols. But it's not always the most efficient use of resources. The diagram on the right kind of shows why. IGMP it relies on a hashing-based algorithm. So it can be inefficient. There can be an inefficient use of resources if you have multiple links. So you might have one link that gets more multicast groups than the other links. Now that might not seem very bad in an environment where you're transmitting just a couple gigabits per second, like in my drawing here. But as you expand and grow your network to more 4K or UHD workflows where the bandwidths are enormous, it leaves you open to a possibility of what's called oversubscription. So that's where a link that's dedicated that supports 100 gigabits per second only supports is getting fed through, say, 120 gigabits per second. So it's more than it can support. That's really bad for video. That means your video goes black, broadcasters get unhappy, advertisers get unhappy. So IGMP is not always the way to go. That's where an SDN comes into play, software-defined networking. That's where you have a network controller kind of sitting in parallel with the broadcast controller. So we don't need to rely on IGMP here. We rely on the network controller, the SDN layer, statically mapping based on the bandwidth of your specific workflows, based on your workflow, based on bandwidth going throughout the network, and it chooses the best path. IGMP is like me saying, I'm gonna drive from my home down to the ACC to watch a Leaf game. I know how to get downtown. I know how to get there. So I'm just going to drive down there. But I might be really late. I might miss the first period. Whereas an SDN is like, GPS navigation. It avoids any of those congested routes. It avoids the bad, it avoids, again, the accidents. It avoids all the, everything it should avoid, and takes me on the best route possible from the source, my home, to the destination, the ACC. SDNs are becoming way more common now. And that's because, again, the size of the workflows, so the 10 gigs per second, for example, of UHD streams, with just the sheer quantity of streams going throughout your network. There are systems right now that have over 100,000 of these multicast groups today. And it's just enormous. You cannot get away from a system. You cannot rely on a system just with IGMP sometimes. You need that finer granularity that an SDN offers you. So overall, networking, especially in media workflows, it can be different. There are a lot of verticals out there. Media is a bit unique, has a heavy reliance on PTP, precision time protocol, for referencing your signals, and has an extremely heavy reliance on multicast. There might be some headaches. There can be some headaches, but it's very valuable information. Our lives are becoming more networking centric every single day. So it really is, again, very valuable information. And of course, everyone here, who's ever interested in this, just practice. Look at certifications, build some virtual labs if you want. There's a lot of ways of learning networking that will really help prepare you for the, for today and the future as media becomes more IP centric. And if you have any questions, my email is there at the bottom, rmorris@arista.com. Thank you very much. And thanks again.
Thank you, Ryan. We had some good questions come up, and we've had some Phil and others sort of responding to them. So
Sure.
Thanks to everybody. And again, students, please don't hesitate. If you're unsure about something, even in the middle of a presentation, please just post a question in the Q&A. So either the the speaker or one of the other panelists could try to answer it for you. Thank you again so much, Ryan, for
No problem.
making that understandable for a lot of people. Really appreciate it.
A lot of protocols to understand. It's yeah, there's a lot to learn. But thank you.
Ryan. Okay, so next up we have Brian Campanati. And Brian is a published author, patent holder, successful serial entrepreneur. He's recognized as a thought leader and innovator in the areas of massive scale on-premise and cloud unstructured data storage, archive, and preservation. He founded Cloud First IO in late 2017, focused on digital archive transformations in media and entertainment. Prior to this, he was CTO at Front Porch Digital for 13 years and helped guide the company through several transactions, including its acquisition by Oracle in 2014. He also founded MassTech and began his career at the CBC in Toronto as a broadcast engineer more than 2 decades ago. He holds an electrical engineering degree from the University of Toronto. He and his team have won 3 Emmy Awards for innovation in serial digital video, long-term content preservation, and most recently for pivotal contributions to the industry in the area of digital archive technologies. Thanks so much for being with us here today, Brian, and I'm sure we'll have lots of questions coming up.
So what I'm going to talk about today is actually a sort of pivotal shift that we're seeing or experiencing right now in media and entertainment, really around the area of cloud storage, archive, and preservation. What I'm going to do, though, before I sort of get into that, actually, I'm not sure if I'm going to steal your thunder, Tony, but I wanted to mention this as well as as part of Cloud First sponsoring this particular SMPTE event, we're going to be awarding 5 books, which are sort of state of the industry reports on technology and media and entertainment. And it happens to feature a chapter by myself on archive and preservation. So I think we'll provide you with a little bit more detail on this later on, and wish you all good luck. So what when I was asked to present here today, thinking about me back in your shoes as a student was really what I wanted to try to do was trace my career path over the past few years, to be kind, just to kind of give you a sense that you may start off in television technology on one aspect of the business and end up somewhere totally different by the end of the day. So as mentioned in my not so brief bio, I started with an electrical engineering degree, from the University of Toronto, long time ago. And my areas of focus then were autonomous robotics, neural networks, fuzzy logic, sort of all the precursors to modern day AI and ML, which is kind of interesting that, a few decades ago, people were working on this type of technology. So, back to what Troy was talking about, there are fundamental things that SMPTE is involved with today that really won't take significant impact or have significant effect on the business for years. I started my career at the CBC as an engineer, working. This was I got my first taste of digital video and files as a replacement for videotape. So this was really what set the career trajectory for me as time passed. While I was there, the team there won a technical Emmy for innovation in serial digital video, similar to the shift that's going on right now with the move to IP-based video as well. So, kind of an early move to a shift in the industry. When I left the CBC in the late 90s, I founded a company called MassTech, which is still quite alive and relevant today. We were designing first media and entertainment focused digital archive systems. So really leveraging IT technologies for massive scale storage of video assets now at the advent as the industry moved away from videotape towards digital files as well. After that, I tried to dodge out of media and entertainment technology, and I started a company actually on the consumer side of the world, which was the first consumer-focused real-time power consumption monitoring system. And I purposely chose that icon above. We were a little early to the game there with the idea of people actually caring about consumption, and now 2 decades later, you can jump on Amazon and buy devices that were quite similar to what we were designing back 20 years ago before, tablets and mobile phones and things like that. So, again, what was interesting about, my time at MassTech and with PowerWatch was really we were being exposed to the world of finance, right? Raising capital, venture capital, getting involved with private equity firms, raising several rounds of funding to help support the business. And, the atmosphere in Canada it ebbs and flows, sort of year over year and decade after decade. But, there are a lot of programs available if you do have innovative ideas in technology and, certainly around media and entertainment. There are a lot of vehicles for you to bring that technology to market. After that, I joined Front Porch Digital as CTO. I mentioned I was there for 13 years, went through several internal acquisitions. We listed publicly, we delisted publicly, we spun off, we had a sale to a PE company, and then eventually we sold to Oracle, which was quite an experience to have our 150-person company absorbed by Oracle there. But, really predominantly still very focused on digital archiving and media and entertainment. And in fact, we built and deployed still the world's most widely used digital archive platform in media and entertainment called Diva. During that time, we won an Emmy Award for migration of videotape assets. We had some technology and some IP around massive scale migration of videotapes and film into digital for storage and preservation as well. And after leaving Oracle then at the time, in 2017, I started Cloud First. And Cloud First is really helping to transform the industry around these legacy on-premise storage infrastructures and archive infrastructures, and embracing cloud services really around massive scale digital archiving. Soon after, back just a couple of years ago, actually I received an Emmy Award for MassTech, actually, way back 20 years ago. And that was a really meaningful one for me because looking back, I'd spent about 20 years designing, building, and developing these large-scale digital archive platforms and software applications to manage them at enterprise scale. And this was really for early innovation and early development of these systems that played a pivotal role in the transition away from videotape to digital file-based technologies. And recently, just last year, I was co-author of a book that we're going to be giving away today as well. So that was a nice culmination of a few decades worth of experience in media and entertainment and technology. But you'll see, I stayed in the area of technology and really software development predominantly for the past 20 or so years, and had a lot of exposure as a result. 3 startups, a lot of exposure to funding and building companies and the challenges that we face at a global scale and things like that. But it's really been it's been a fun ride. It was fun putting this slide together and kind of looking back and remembering back to all these experiences. So without any further ado, really what we're seeing in industry trends, and I sort of presented this same slide a couple of years ago, and essentially with the exception of a pandemic, really things haven't changed very much. And in fact, all of these have continued to advance and accelerate, if not. The things that we're seeing in the industry is really about vendor and media company consolidation. In Canada, especially, 20 or so years ago, there was 20 or 30 or 40 or 50 broadcasters that we would all go out and try to work with and sell, and new people that worked at, and we're trying to track what they were doing in terms of innovation. And through consolidation, really a lot of those have been rolled into the larger umbrellas of Bell Media and Rogers as well. And it's not to say that that stifles innovation. That sort of drives a lot of companies for scale innovation as well. But certainly there's a lot of place for smaller level innovation. So for every large company that provides technology into the media and entertainment business, there's probably still 1,000 companies that are small niche providers of particular parts of the workflow. So I certainly encourage you to innovate, to think outside of the box. And I think what this industry needs generation after generation is new thoughts and new perspectives on what we've been doing for a lot of years. Certainly a move away from dedicated hardware to virtualization. This is core to just about every aspect of the media business, and certainly a lot of other industries as well. With the pandemic, certainly in the last couple of years, there's been a big push from on-premise production to remote productions, and this is people working from the parks around their homes, from their basements, and setting up little studios. But the key thing here is really about secure data accessibility, tools that can be run on more modest compute power, laptops and mobile phones and things like that. The importance of sort of user-generated content, whether that be by professionals or by just citizen journalists, and the contributions and the acceptance of that as sort of broadcast. And the mobile devices have advanced to the point where we have 4K sensors in a lot of them, and they can record pretty compelling content natively. From a technologies perspective, there's been a big move away from perpetual software licenses to, whatever as a service. And I think, we've all seen this from, things as simple as Microsoft Office, which we used to buy for, $299 or whatever, and then have to buy again every few years and, figure out whether our old files are compatible. The industry has really moved to consumption as a service, and whether that's, utility cloud services like storage and compute, to software licenses and applications, user interface, user seats of particular applications and platforms. There's really been a big move in that direction. And, certainly that comes with its challenges as well. There's no capital investments anymore. It's a lot about operational expenses, and, if left unattended, operational expenses can add up and become crippling to an organization. And then the last thing around around technology is, back in the days when I was working at the CBC and various other companies along the way, all we cared about was technical specs. We cared about the specifications of the storage technology, and what the MTBF failure rates were on the devices, and what type of technology it used, what magnetic particles did it use, and that's really changed as well. And that's across the board. It's not just a media and entertainment thing. So we've seen a move from people caring about the specifics of the technology to caring about something called SLAs, or service level agreements. Basically, how are you going to protect my data? How are you going to guarantee? To what level are you going to guarantee my data is accessible? And essentially, how much are you going to charge me for that service? And we've seen it all on our mobile phones. Of course, we don't, well, most of us don't know where our photos are being stored, if they're being stored in iCloud or on Google. We just trust that they'll be there. We trust those providers to provide that service to us. In some cases, it's free. In some cases, it's pay as you go. But if it happened to be gophers running on treadmills storing the data, it's not like we're asking the questions. We just want to have our data when we request our data, and know that it's safe. And that's a big paradigm shift for the industry as well.
Brian, before you go to the next question, there was
Sure.
one question relating to what is meant by virtualization.
Oh, sure. Yeah, that's a good question. I think it's almost similar to what I was referring to with, software licenses to XYZ as a service. In a lot of these, cloud environments, and now even on-premise environments, we used to have racks and racks and racks of servers, big, expensive, high-power servers. And unless that server was running a specific task at the time, it was just basically wasted resource and wasted energy. So the move towards virtualization started, quite a number of years ago. And what that allows you to do is basically run what look like servers, full operating system, applications, et cetera, and you can run many of those on a group of server platforms. So essentially, you can consume, or try to consume, as much of the compute power of those servers, as much time as you possibly can on a consistent basis. And this is exactly how the cloud works. If you start a server up in the cloud, you're not getting your own, bare metal server with Windows or Linux installed on it. You're getting a slice of a virtualized piece of hardware there. And of course, you can scale up and scale down. But part of those virtualized infrastructures is they can take care of things like redundancy, fault tolerance, scale, and they're at the core of every website that you visit, every modern deployment of software now out in the business. But at the most rudimentary level, it's a way of running many virtual computers on a single hardware platform, or on a group of hardware resources, whether it be compute, storage, and memory as well, sharing the infrastructure. So just a quick highlight, when we talk about storage, mobile phones now are in the 100, 500 gigabyte storage range. I know that there's some phones now where you can actually buy with a terabyte of storage. It does seem like a lot of storage when you're dealing with photographs and videos from mobile phones, but when you're dealing with media and entertainment content, really the storage is a big challenge. So this small chart is an excerpt actually from the book, highlights standard definition content is nominally 50 megabits per second. And if you look right across to the right-hand column, essentially 1 hour of content in SD is 22 gigabytes, HD is compressed HD is 44 gigabytes. And as you go down, if you look at uncompressed 4K, you're now into 5 terabytes, which is 1,000 gigabytes, 5 terabytes of data for 1 hour. So that, of course, is a lot of storage. But when you look at a normal media and entertainment company like the CBC, Rogers, Disney, they have hundreds of thousands of hours of content. So this is really when you look at the exponential challenge of storage in media and entertainment. So just a little insight here on storage technologies, starting with something a little bit humorous, hopefully, is, one of the earliest data storage technologies we had was stone tablets or hieroglyphs or things like that. Roughly 3,000 or so years ago, I did some rough calculations, and you could probably store about 1 to 7 kilobytes per tablet of data. Very slow read and write speed because somebody had to chisel that in. But the good thing of it is it had very good data retention. In fact, we're finding those storage devices today and are able to decode them and access the data that they stored. If we sort of fast forward to the advent of data tape technology in media and entertainment, this was one of the most famous technologies at the time, which was a storage tech powder horn. This was circa late 1990s, 1997, 1998. And I put a car there just to give you an idea of the scale. And inside of there is a data tape robotic system. So they're physical data tape cartridges. And in this particular design, it was a circular robot that would grab the tapes and insert them into tape drives under control of software like that I developed when at MassTech and at Front Porch Digital. But that entire storage infrastructure, roughly the size of a car, stored only 10 terabytes of data. And it took over 6,000 individual data tape cartridges to store 10 terabytes of data. So, if we think back to that last slide, it would take you a device of that size to store roughly 2 hours of uncompressed 4K video. But back then we were using much less data. We weren't, of course, encoding at 4K. So these were the first ability to essentially eliminate videotape from the media and entertainment workflow. And the life cycle or the longevity of the data tape, if you stored it in proper conditions, was about 10 years, which meant that every 10 years, you had to migrate the technology, migrate to later and greater technology. Of course, with that migration, even though it could be long and painful, depending on the scale of data, of course, if you had to migrate 6,000 tape cartridges, it might take years to do that. But with each new generation of technology, you've got faster performance, higher storage density, hopefully higher data resiliency, et cetera, et cetera. And then if we fast forward, really only 8 to 10, well, let's say 20 years to present day, LTO tape technology became the sort of de facto standard. And each tape cartridge, I apologize, I meant to have one here, but I don't have one handy with me here. But the tape cartridge is roughly about this big and maybe a couple centimeters high. And the current technology, LTO9, which is the 9th generation of LTO technology, on a single cartridge can store 18 terabytes of data. So almost double what that powder horn stored with 6,000 cartridges can be stored on a single data tape. So, there's been exponential advance. So, moving from data tape now, the most compelling move now is towards public cloud. And There are many cloud services, and I put 2020 onward here because really that was the advent of archival applicable storage in the cloud. So meaning cost effective, resilient, et cetera, et cetera. And this is Microsoft and AWS and Google certainly all offer kind of cloud archive tiers, which are now viable to replace what was traditionally these on-premise tape infrastructures. And then looking forward, there's a lot of work on what's next, and ones like, and you may have read about some of these DNA-based storage, where essentially they take ATCG sequences and lay them out in an encoded fashion where we can basically use DNA to encode data. Quartz etching. Recently, there was some articles on ink printing, basically for long term, which is kind of funny. It's almost bringing us back to the stone tablets when we look at quartz etching and ink. Currently, very, very slow read and write speeds, to the bytes or hundreds of bytes per second. So absolutely impossible to store data on them today. But who knows? But what we're looking at is something that could last for the millennia, right? Basically being able to store your data once and not have to continually migrate. So this is really where we are today, and certainly my company is focused specifically on this transformation, move off of on-premise complex data tape systems and to embrace these modern cloud infrastructures. And again, this is really the inflection point that we found where 5 years ago, people were caring about whether it was, barium ferride substrates on data tapes and what the, potential areal densities were on these particular data tape medias, to now trusting and knowing that the cloud providers provide, published SLAs around things like data resiliency, data accessibility, corruption rates, 5 nines or 11 nines of resiliency of data and durability. So it's really taken some time for media companies and broadcasters to get their heads wrapped around this, letting go of their content and embracing the cloud. But the truth of the matter is that services like Netflix were essentially cloud native from the start. So the content is in the cloud already on these very secure, very protected infrastructures, and staffed and managed by thousands, if not tens of thousands, of the world's best infosec people, the best encryption people, the best storage technology people. And in these cloud infrastructures behind the scenes, there are a mix of just about every technology. But again, really what they're exposing, or the cloud providers are exposing to us, is a stated SLA, and we decide whether it's applicable to what we're looking for in terms of target storage. But again, we're all doing it. It's all where our cell phone videos are stored. All of our banking information is stored in the cloud. And let's say certainly over the past couple of years, a lot more media and entertainment content is now fully cloud native. When we look at helping clients through this migration, again, back to the scale, all of these on-premise data tape archive systems are usually in the petabytes or tens of petabyte range. In some cases, they're over 100 petabytes of scale. For those of you that aren't familiar with the term petabyte, it's gigabytes, terabytes, and petabytes is next. So petabyte is 1,000 terabytes, terabytes are 1,000 gigabytes. So just to give you an idea of scale. And those types of migrations can take years to complete, depending on the scale of that. And one of the challenges is, as we're helping a client to migrate into the cloud off of these legacy platforms, their broadcast business doesn't stop, right? Production continues, news operations, broadcast, play out to air still continues. So essentially, it's finding the balance between stealing the sufficient amount of resources and technologies to be able to facilitate the migration. The other thing is that a lot of workflows have been built around these legacy archives. So being able to decouple the applications from the underlying storage is sometimes not quite so straightforward and takes a lot of additional work. again, because we can't just tell the broadcaster to stop what they're doing while we figure all this out. So it all has to kind of be done live in a very, very sensitive way. The next thing is that the applications that these organizations use might be, so fully ingrained in their environment, but might not necessarily be cloud aware. So just migrating the data to the cloud doesn't necessarily mean that the organization will gain any benefit. So, really working on a transition and a transformation plan to make sure that there is a way to leverage this content once it's migrated. A lot of these data tape infrastructures are aging as well. And, if they're going to be driven very hard during a migration process, they can be fragile because they are mechanical devices with big, powerful robotic arms and, data tape on a very thin data tape material. So we have to take a lot of care around that as well. And, once we start putting all this, these challenges together, really the idea is here, it's going to take a long time. We know that. Don't panic, but the sooner that you start planning, the better off you'll be, because the problem isn't going to get any better over the next few years. And really what we focus on, just sort of wrap this up, is the most important part for us is about data empowerment. So we do have a data sciences capability within our organization. And the idea there is before we even start working with a client about looking at or starting to develop, an archive migration plan or an archive transformation plan, we do a very, very in-depth analysis of what they've done in the past. So how do they use their environment? What type of resources? How do they use their data? What workflows does it serve? Things like that. And we use that data empowerment to essentially drive data-driven decisions, to bring the client into the new world in a very informed fashion. And from there, we do build services and technologies to help with the lift and shift. But the primary focus here is really about enabling the client with data and ensuring that they are fully aware of what they're getting themselves into as we help them embark on this archive transformation journey. So thank you.
Thanks so much, Brian, for defining all that for us. We really appreciate it. And I'm sure we'll have more questions at the end as well. So next up, we have Jerry Autoto from TFO. And Jerry, through real-time visual effects and quality control, Jerry has been rethinking and evolving virtual environment workflows within the mainstream media studio productions. Having worked in many facets of virtual production at Group Media TFO, has allowed him to master this new technology while developing new methods that allow the studio to efficiently produce high-quality content. Today, having spent over 10 years working in broadcast and media production, Jerry has demonstrated leadership in the fast-paced environment and contributing to a variety of technical workflow optimization and infrastructure projects. And I know Jerry well. We've worked on a bunch of projects together. Thanks so much for being here with us today.
Thank you for having me. I'm going to share my screen. All right. Everybody see? Yeah. So thank you very much for having me. So today I'll be talking about virtual production and how to innovate with gaming. Seeing as this is like a very visual subject, I thought we'd just start off with a little with a video.
We've been waiting for you.
Oops.
All of this flexibility right at the tips of your fingers. Technology so advanced that we are now limited only by our creativity. Let's make something extraordinary.
So this is actually a promotional video that we had done just to encompass all the possibilities of our virtual production studio. But I'll touch on how it was made later. But move forward. So Groupe Média TFO. Groupe Média TFO is a Franco-Ontarian public media company offering award-winning content on television, digital platforms, and through initiatives and applications. So what that means is that we provide educational content. So as you know, when you provide educational content, it has to motivate learning. So much of what we do in the LUV, which is the Laboratoire d'Univers Virtuel, or in English, the Virtual Universe Laboratory, a lot of what we do in the LUV in virtual production is really centered around the development of broader educational initiatives, right? The implementation timeline, let's say when we looked at the studio, it all started in 2015. So we wanted to see how we could innovate and really bring something new to our productions. So we were looking at something in the virtual world for some time, and we ran some tests with using gaming tools such as Unity and Unreal. And we finally landed on some tools that really, from the gaming industry, that really fit the bill. So in April 2016, we landed on the Reality Suite from Zero Density. But this set of tools really bridged the gap between broadcast technologies and the gaming world. So later that summer, we opened one of the first, if not the first, virtual gaming-based real-time production facility in the world. So since then, we've added some technology to enhance the studio's capabilities. So we started doing ray tracing as the gaming tools kind of started evolving. We started using BlackTrack's tracking technology for talent tracking, implementing 4K cameras in one of our UHD cameras into some of our productions. We've really kept up with industry trends and practices, and we've mostly, and that's a big one for me, is we've optimized a lot of our workflows so we can work efficiently and really maximize these tools. Now we're actually currently working on transitioning into a UHD capable facility. So we're still growing and we're still evolving as far as virtual production. So really there's many benefits to 3D virtual productions. The key ones that really stand out is the ability to integrate hosts and actors into a 3D environment and really make it look like they belong in the environment and do the compositing in real time. So there's exceptional details of design. So you're able to really bring elements from different worlds. So whether it's like a fantasy type of virtual set, or it can be a more photorealistic virtual set. While there's technical limitations, of course, in regards to hardware, there's still a lot more creative freedom as far as virtual production. So if you're dealing with live production, you can use the real-time gaming engines to do live production. But at the end of the shoot day, you can walk away with fully composited projects. So you really get an end result and you'll save on post-production time. And that's not to say that post-production is impossible. There's different workflows as well that allow you to do both. Which brings me forward to pre-visualization, for example, or pre-vis as some call it. So while you're on set, you can really view and see everything that's happening in real time with the real 3D set in the background and everything. So real-time rendering allows you to get an idea of what the end result will look like, as opposed to traditional workflows where you had to either guess or composite one scene on location, and that only gave you kind of a sample. So it's really a benefit for those who still want to do things in post-production, but want to get a better visual and a better idea of how it's going to turn out. So yeah.
So Jerry, a question came up. What is real-time production and how does it differ from regular production? And I think this refers to sort of real-time virtual production as opposed to, I guess, post-produced regular production.
That's actually an excellent question. So real-time production kind of refers to, back in the traditional days, you would shoot your talent in front of a green screen and you would take that to post-production, and then you would have 3D animators animate a whole background and then kind of composite or bring these two images together and integrate both of them together. So when we're talking about real-time virtual production, we're really talking about the 3D background being rendered and recorded at the same time as the green screen. So essentially, what we're doing is, well, in the particular case of our studio, we're using a green screen, but there's other virtual production setups where you can use an LED wall and others, and I'll touch on that later. But the advantage there is that you're removing the green screen, the green from the image, and you're putting the 3D background right away, and you're recording it, and you get a final product walking out of the studio. So that's kind of how you save on time. Of course, there's pre-production involved, and there's other different workflows when it comes to virtual production.
Like the video demo you showed was basically could have been done all real time without any post-production, except for a few edits. So all the interaction and everything.
Yeah, exactly. All the visual effects you saw in that video, they were triggered in real time on the day of the shoot by operators, cameras, and so everything was done and tracked in real time. We still shot it scene by scene. So the only editing that was done was really the assembly of all these scenes together.
Thank you.
So yeah, gives you an idea. So as far as virtual production tools, there's more and more tools available every year. The tools kind of bring benefits in two different ways, actually. So on one hand, they allow us to increase quality and precision. And on the other hand, they allow us to really maximize performance. And what we mean by that is that we're able to work with photorealistic environments and low light situations while using advanced skiers. So that means that you can be so much more precise and really remove do you guys still see me, hear me? Yeah.
Yeah, you broke up just once or twice.
Perfect. Apparently Zoom was telling me it was quitting. It's all working?
It is, but you're breaking up a bit. Oh.
I was just going to say, maybe you should douse your camera to if you're bandwidth challenged.
Go ahead, carry on, Jerry, if you want to put your presentation back up.
Yep, putting it back up. Yeah, Zoom was telling me it was quitting unexpectedly. There we go. So do you guys see everything? Yeah.
Yep.
Okay. Yeah. Okay. So yes, so I was talking about precision and advanced keyers. So really, you can be much more precise with advanced green screen keyers, and so you can get some of that detail that was kind of harder to get back in the day. So really, so details in the hair, for example, and that sort of thing. So that's what we mean by precision, as well as like green spill suppression. And then as far as low light, so you'd be surprised to know that the video I showed you guys earlier was very low light in the studio. So the green screen was actually barely lit, and we were still able to remove the green from the image and really composite it. And as far as performance goes, it's now possible to use GPU acceleration. So you're using the PCs themselves to really improve the performance. So what that means essentially is that you can maximize the hardware, and you're able to have more visual effects and more elements on screen at the same time as technology kind of keeps evolving. There's also various background applications. So as far as like using LED screens or green screens, there's flexibility there. So you don't necessarily have to do green screen anymore. You can have a big LED panel showing the background. There's tracking tools for talent as well. So back then we used to only track the cameras. Now we can track the talent, and it's very efficient. This is just kind of to give you an example of what we see in the studio, and this is all happening in real time. So on the left there, you see on the green, that's actually the shot without the background integrated in. And then on the right there, where you're seeing the hand, the background's actually integrated, everything's keyed. And when the camera moves, the background moves as well, and everything's calculated in real time. And you're seeing there as well, the little smaller screen there with the nuggets. This is like final composited shots. So yeah. This particular production, we were looking at pre-visualization, so we wanted to know what it would look like in post, but this could have been recorded as well and used the way it was. When we talk about real-time talent tracking, Real-time talent tracking uses a tracker that the person wears like a microphone. So it can be hidden behind fabric. So that's where technology has taken us, which is great. But this allows the gaming engine to really understand and calculate the position of the person walking around in a 3D environment, right? So this here is an example that you're seeing there. You see there's a pillar there right in the middle. The talent can walk both behind the pillar and in front of the pillar and then walk back behind the pillar because he has a tracker that tells the engines or the machines exactly where he is in the 3D space. So this before talent tracking, well, I mean, talent tracking has existed for a while, but before these better applications of talent tracking, you had to manually, if you didn't have a talent tracking system, you had to manually set if the person was behind or in front. So this is really how we're evolving and how things have progressed and how much easier it is now. As far as our studio, this is actually a picture of our studio. You're seeing 3 cameras there. So this is what we call real-time camera tracking. So what that means is that for each camera you see, we use camera tracking on both the pedestal camera and the jib. The jib uses more of a mechanical approach for tracking, using gears and measuring their movement. As opposed to the pedestal cameras, tracking is done using stickers on the ceiling, which you can see a little bit on the lighting grid there. And basically the camera will calculate its location in the 3D space just based on these stickers that you're seeing there. So if we move forward, you'll see here, what you're seeing here is this is what the tracker camera sees. So the tracker camera is actually pointed upwards on the pedestal. And this little screens will show us the mapping of the stickers that are up there. So you'll notice optical good is written there. And what that means is that everything is working and the tracking is optimal. Whenever that camera moves around, up, down, left, right, pan, tilt, zoom, tracking info from the camera and the lens itself is sent back to the 3D virtual set engine, and it'll determine what the virtual background should be. So, and it'll figure out the background, the field of view, and the focus. So this is all calculated in real time, as opposed to someone in post-production having to decide, oh, if this camera was this zoomed in, the background should be about this much blurry, let's say. So this is how it saves a lot on production time and so forth, and post-production in particular. So gaming in film and television. Now, you may have seen many applications of this. As far as TFO goes, we do children's educational programming, we'll do cultural and some corporate as well. But you may have seen the Oprah conversation, an interview that was done with President Obama. And essentially, they were at 2 different locations, Oprah and President Obama. And through virtual production, they were able to bring them into one image as if they were sitting across from each other and having an interview. And the cameras were moving, but it was a green screen. So therefore, you can animate a background and it looked like they were in a living room and that sort of thing. So really shows you what's possible nowadays. Now, you may have seen some of those other ones like Mariah Carey's Christmas special. The Weather Channel USA uses this technology a lot, and a really popular one is The Mandalorian on Disney Plus. So yeah. We wanted to give you a little spotlight on TFO virtual productions. Kankazoo is actually a project that's still in production right now. Here's some concept art. It's a camper. So the series really takes place on a campground. We follow the characters Annette and Babette, who are the main characters. They're 2 goats that play music. They have fun and educate children through everyday situations. So they're brought to life in a dynamic virtual set environment, which you'll get to see in a second. There we go. So it's stylized as children's content. This is a view of the playground. And if we move forward, you'll notice a very large environment. So it gives you an idea of the vastness of the world that can be designed and created in the 3D. But also, if you look at it from a logistics point of view, you can imagine the logistics of just renting a campground and having to shoot in all these different locations. So, and the cost as well, right? So with a virtual set like this one, it has multiple predetermined presets, which allow us to jump from one location to another while the physical set dressing is actually happening in the studio. So the whole team can just keep working in between takes, and everyone can work because they can see the end result on the screens in the studio. So everything is done in real time. Here's a little bit of one of the campers, for example. So the 3D design team will work with the props and set design teams as well to make sure that everything's coherent. And the virtual set compositing team will make sure the integration looks good as well. So I wanted to show you a little clip of the show so you can get an idea.
There's no audio playing, Jerry, in case you wanted.
Oh, it's okay. So here you're seeing an interesting thing you're seeing here is that the fence in the front is actually a wooden fence. So that's actually a prop. And if you notice in the back in the intro shot, part of the fence is actually 3D. So we're actually able to implement and scale things accordingly. And what you're seeing here is the puppets and so, you know, obviously we'll mask out certain things so we don't see everything. So this is what you're seeing as an end result. But if we move forward, oops, onto the next slide, this is actually the talent in the studio. So the puppeteers are working here, and we can actually mask them out. They're wearing green as well in case their head kind of pops up in the shot. But essentially everything under that big table in the back is kind of cropped off. And then so this is just a little video of them rehearsing. But the idea is that now it's possible to even mask out some areas, which is why we don't see any of the floor, even though the floor right now doesn't have any green on it. So there's really a lot that can be done now. Another little thing I wanted to show you is it's another show called Ce n'est pas de la magie, c'est de la science. It's an educational program about science. So the concept is that the main character, he's a magician and he does science experiments, but at the end of each episode, he kind of realizes that what he's doing is not actually magic, it's just science. So you'll see a little bit of that just to give you kind of an idea of what is what. So here you're seeing he's walking down the stairs. This is actually a green staircase that we use and we integrate with the 3D space. Here you're seeing, you know, the little drapes and everything. Like all this is real physical set props. If you look at the bottles, you'll notice how well the bottles are kind of keying there. So that's what we mean by kind of precision and maximizing the technology that way. So yeah. So I'll move on to the next slide. Whoops. There's other things, other applications. So for example, gaming tools can be used to create architectural design. This is an architectural design of Penn Station in New York. So these models can then be brought into Unreal and turned into virtual sets. And what that means is that now we can create a feel for the space and with actors before the construction begins, because you know all these things are modeled in the up to scale. So yeah, it gives you an idea of what it looks like. So everything here is virtual and 3D except for the talent that you're seeing there. There's another, I mentioned the Oprah conversation earlier. Virtual interviews are also a thing. So this is kind of an example, kind of a proof of concept that we had put together at the time. But the talent is really at a different, both talent are at different places, and they're having a virtual interview that way. But on screen, it looks like they're in the same space. And to come right back to the video I showed you at the beginning, I'll give you just a little bit of details of what went on to produce this thing. You'll notice that we can do a lot of mood lighting now and kind of really create a nice mood for the video, playing with colors, real actual lighting, as well as virtual lighting.
Thank you, Jerry.
Oh, sorry. Oh, yes. I'll mention that Rick did the lighting on this one. He was lighting director for this video in particular, which he did a really great job. We can also have some bright scenes added behind because the images are virtual and do not, we can have, yeah, they do not emit light. So what that means is that you can have crazy, really great contrast. So you're seeing a really bright space and the outside is just much darker. And then you can apply that kind of virtual lighting onto the talent as well. And you can combine that with actual real physical lighting to really integrate the talent. This high jib camera shot that you saw when the whole cave was collapsing in the floor of rocks, it required a little bit of rehearsing because this was all done in real time with the jib. So the jib had to get the movement just right. And the rocks falling apart was triggered by an operator in studio in real time. So the talent could see all this happening in real time. So with a bunch of rehearsals, we could just get it right. So what you're seeing here is an extreme wide shot. So this is actually just a virtual zoom out to kind of make the space. So we scale the talent smaller and make it look like it's much bigger than the space we have. There's a tracker hidden behind the boot here. And what that means is that when they step forward, the ripple effect will trigger. So this means that there's a collision detection between the foot and the floor. And that will trigger water ripple animation in real time as the person is stepping, as opposed to having to animate all this frame by frame in post-production. And these white particles are also affected by the talent tracker. There's a talent tracker on the hand. So they'll disperse when the talent gets near and so forth. And that final particle that you saw turn into a butterfly, so that was like programmed to react to a certain movement, but a manual command just kind of happens in the studio and launches that visual effect. So yeah, just a nice shot as well to kind of show the integration and how, you know, the background really blends in with the foreground and so forth. So yeah, we've won a few awards, the Innovation Awards in Content Creation and Judge Prizes at IBC. We're still having a lot of fun innovating and finding new creative ways to use this technology. And I gotta say, so far it's been really cool. And it's always fun to follow up. I'm a very big gamer myself. So I love to watch what the esports teams are actually doing with virtual production nowadays. So yeah, thank you very much for listening.
Thanks so much, Jerry. So next up, we're very fortunate to have Afsoon Sodhi with us. Afsoon was here, I guess, the past 2 years, been kindly doing this presentation to the students. So Afsoon has a PhD in physics from Washington State University and currently leading machine learning developers and data scientists in CBC to develop data-driven systems for CBC content. Afsoon co-founded an award-winning software company, IRYS Tech, I'm not sure if I'm saying it right, which was acquired by Forensia. As a tech entrepreneur, she leads a multidisciplinary team of researchers and developers on technology commercialization and developing ML products for B2B and B2C use cases. As a leader with significant experience in team building and people development, she empowers teams to make good decisions, build alignments, and elevate engagement with her technology vision across a team and an organization. Afsoon is passionate about empowering women, specifically in science and technology. She volunteers her time for mentoring founders and individuals in their growth, serving on the Society of Women Engineers Toronto board as the Director of Industry Outreach. She empowers more women engineers in Toronto and connects industry partners in the region to SWE. Thanks so much, Afsoon, for being with us here again today.
Thank you so much. I'll just wait for a quick second. I need probably access to be able to share my screen because Zoom also mine got disconnected. So I appreciate if somebody can give me access again.
Tony,
okay. Let me see if I need to.
Thank you, Tony.
Here.
Yeah, while you're waiting, it has been a marathon of great content so far. I definitely encourage people, if they've been sitting in front of a computer, just get up and stretch a little bit.
Yeah, you should be able to take
Thank
control.
you. Yep. Yep, it's working. And thank you for sticking around. You should be able to see my screen
Yep,
now.
there.
Okay, perfect.
Thank
Yeah,
you.
you're good.
Perfect. Great. And thank you, Rick, for the introduction. This is great to be here virtually with everybody today. And I'm speaking to you today from the city of Toronto. We're meeting on the traditional territory of many nations, including Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and now home to many diverse First Nations and Inuit and Métis peoples. My name is Afsun, pronouns are she and her, and my new pandemic hobby is baking. It really helped me to center myself and stay resilient. We have been in this together for the past 2 and some years. So I'll try to keep it short and let you guys get to your, and ladies to your evening, get to your evenings. A quick disclaimer, everything here is going to be just my personal views. And a lot of the data I'm using is reference. And if you want to reach out to me and connect, if any of them seems interesting, please connect. I'm happy to share the source of all the data that I'm sharing here today. And I'm hopefully going to give a little bit of an overview. It's a less of a technical talk, an overview of our media landscape, where I'm with CBC so far for the past 3.5 years. Share some of my learnings, and share a little bit about what are the challenges and how machine learning is able to help with some of that, and what my teams are doing at the moment. It's a busy slide. I would like everybody to maybe just take a few seconds to look at this. This is the map of the media entertainment world in the broadcast sense. And it has been produced by Ivan Shapiro, who is a veteran TV executive and an adjunct professor at NYU. He has been updating this slide or actually infographic for the past 2 years monthly, and it has been changing quite drastically. What it shows is the market share of all these companies who are now considered part of the media universe. You can see big companies like Amazon and Apple and Alphabet and Meta, like big circles, that they're the empires. And you can also see some information which is color coded. For example, the red circles are content platforms, purple is gaming, and social is blue. And you might be able to see actually the other ones as well in the middle of the screen. It's mentioned. And some of these circles were not on the map even a couple of years ago, like Discord or Clubhouse, and now they actually have a market share in this big universe. And it has been constantly changing. A lot of this landscape has been changed based on the mergers and acquisitions that has taken place very recently. Focusing on Canada, this is a little bit of information about more stats focused on Canada. And this data, again, I've gathered it from a digital report that just came out this month. It's a collaboration between Beer Social and Hootsuite. That the Canadians spent 3 hours, 24 minutes watching broadcast and streaming. And more specifically, they read media and online, media both online and physical format for 1 hour, 14 minutes a day. The top 3 most downloaded apps in Canada are Zoom, which we're using, TikTok, and Microsoft Teams. And between January and December 2021, Disney was the top mobile app by the amount of money the consumers spend on it. And pandemic has certainly changed a lot of our behaviors toward entertainment and how we stream. A lot of us use mobile apps for work and schoolwork, and definitely gaming. I want to go back here again and emphasize what I want to a little bit talk about is how do we compare any of these companies with each other, and how we determine who's successful. For example, CBC in 2020 has been the #5 visited site in Canada, and every individual person has a limited time span of attention and number of hours and minutes that they spend on media. So how do we really measure success for any of these companies, and specifically for us? So there are a couple of different pillars. One being how many people we attract to our platforms and interacts with our platforms and contents, which in our world, it's called acquisition of audience and basically our reach. The second is how we can keep the attention of these people longer, which translates into audience engagement and retention. And the last but not least is our revenue and how much profit any of this work will generate as a business. All of these business concepts need to be kind of translated from abstract ideas to something that we can actually repeatedly measure. And some of these that we currently use in media, for example, for acquisitions, a common one is average monthly active users, or for reach is the number of unique visitors that come to our websites or apps monthly. For engagement, it's a time spent, and for revenue is the cost of acquisition of any customer. And there are many more of these, and there are a lot of people focusing on them and generating reports and kind of measure that. And the point that I'm trying to make is that journalism is becoming a really computational exercise when you want to focus on how we succeed. One other way to look at our media world is through the value chain that is being created in any business, and I want to emphasize the role of machine learning that and the impact that it has on any of this. So this circle is kind of shows one breakdown of how the value is being created through media. One is the content creation, the other is content distribution. Then we do a lot of advertising and marketing, and also an important factor is content discovery. And machine learning helps with all these aspects, depending on how much energy or time or money and resources we spend on. We could attract more customers by building better products, and we could engage them better. Or on the other spectrum of our value chain, we could lower the cost of our creation, and we can actually focus our open up our journalists' time to not do redundant work and actually focus on the high value part of their jobs that requires human to do it. This one is another one, so don't worry if you're not able to read everything on the screen. It's not meant to. I'm just trying to showcase some of the products that are already in existence in machine learning, that it's color coded, for example, right now on this slide on content creation. there are a lot of tools nowadays being used by small or big media companies to help our journalists and producers for content creation. For example, machine augmented investigation or neural networks for photo tagging, or automating some of our internal processes and generation of augmented text on our content through AI. The next one is content distribution. We have had a lot of management of the paywall and subscription now being done by AI, or a lot of data analytics, and also some of news aggregators that now use machine learning to actually produce. In advertising, a lot of value, a lot of our automated data processing and automated reports and customer service analytics. For marketing, the same, a lot of AI data analytics, internal processes. And the last one is, which I'll be talking a little bit more about, is the content discovery. Aside from the news aggregator, this area is one of the ones that my teams really focuses on, which is personalized content recommendation that I'll get into a bit in more depth, and also predictive analysis, which basically generates trends and patterns of our audience behavior and any visitors that comes to our websites and apps to help our content producers, and also other solutions for our editorial. So AI powered solutions for editorials as well. CBC as a public broadcaster has an additional mandate. Our mandate is inform, entertain, and enlighten all Canadians. So it's a little bit different from business perspective, especially in terms of the content we produce and methods we can use to engage our audience. As I said, my team focuses on at the later part of the value chain to focus on audience analytics and content for personalization. And we build products for great experiences using data for our audience. With the emergence of digital entertainment, these platforms that are our website and app have become really important factors in terms of distributing our content and how our audience interact with them respectively has become very, very important. And a lot of analytics tool can be provided to the journalists and producers to give them a better understanding what type of content would be beneficial to our audience needs and basically the request. And this is mainly one of the focus of one of my teams, that they build an in-house audience behavior analytics dashboard for a content producer. And most of their works I listed the type of things they do. A lot of data collections and cleaning of data and metadata. A lot of the previous talks touched on how important the metadata is and how about storing of the data. And those are the platforms we would use. There are some already in the market, but my team is focusing mainly building a dashboard internal for the specific use of our content producer. They do a lot of data cleaning, analysis, visualization of our audience behavior for content producers, and they primarily use unsupervised machine learning, clustering and segmentation algorithms for their analysis to identify those patterns and uncover hidden insights, basically. And it kind of distills that information into actionable insights for producers and also executives to make data-driven decisions and create a great content for audience. The other major use case of machine learning in my teams is personalization of our user experience, which is an important tool to increase engagement, especially through content discovery. We do that through our recommender system. Surprisingly, humans are really bad at choosing between many options, and they quickly getting overwhelmed in these days that you're exposed to a lot of information, and choosing what content to view becomes a very big challenge, and people can make poor decisions. And a recommender system is basically an information filtering system that tries to predict user preferences. They help user find what they may like. And the core algorithmic core of most recommender systems is a machine learning model that tries to predict which items will get the most engagement. And today's recommender systems use many different kind of user behavior to determine what shows next to the user. But they are mostly using a lot of supervised machine learning as a core. These are the three main type of recommender systems that is very common in the industry right now. The content filtering one is similar, that people might be familiar with what Amazon uses. Basically, it recommends you based on your past views. If you've liked the toaster or viewed the toaster page, they will keep presenting you a toaster until you purchase. The collaborative filtering is more similar to, for example, the one that Netflix has. So all these companies have many variations of recommender system, but just to help people understand what it means, the collaborative filtering is the one that recommends if you watch a movie and another customer watches the same movie and likes a second movie, they'll recommend based on similar users' behavior. And then there is another one, which is the contextual, if I can pronounce it correctly, recommender system, which basically looks at the audience intent, and it's a session-based recommender, and it can vary different times of the day based on what you are viewing, the content you're interacting with, and it's a more of a complex recommender. A few consideration for recommender systems, especially for news, there are different than other companies, digital companies that use recommender, and more specifically, as a public broadcaster, we have a lot of content pieces every day, 400 every day, and hundreds of thousands of users that interact with our content. So the relevancy of our content can rapidly decrease. We cannot really recommend any old news, which would, nobody wants to read a COVID article from a week ago. And also, we also have to make sure that we avoid creation of filter bubbles. If you keep recommending the same things to you, it kind of reaffirms your biases. And people taste might change actually over time and during even one day. And the ratings that they give to any content may not actually reflect what they who they are and what they want. So the potential harmful effect of optimizing for engagement is really high when it comes to news and promotion of conspiracy theories to increase political polarization to addictive behaviors are consequences if you're not really mindful about that. So the trust of Canadians are really important to us, and our recommender goals are more nuanced. So the one that we're working mostly on for our news is the session-based recommender system, which circumvents a lot of the side effects that I specifically mentioned earlier. And we make very specific algorithmic choices and thoughtful in how we use users' data. Our algorithm is a deep learning algorithm, which is recurrent neural network, and it uses sequential data and allows us to make predictions on behavioral signals. It reflects how people are interacting with CBC and predicts real time. And it does not actually rely on the content of that specific article yet you're interacting with. I hope some of this would be interesting to you, and with that, I'll pass it over.
Thanks so much, Asun, for that very insightful presentation, and also for the land acknowledgement, which we should have done before. Thank you. So next we have Phil Englert. Phil is, I'll wait for the slide to come up. Phil has worked in live production for 10 years and has spent 5 years as a game and directing specialist for world-class esports events. His goal has always been to deliver the most game-authentic, format-relevant, and emotionally impactful stories to the audience and community. Some of his credits include game directing the Fortnite World Cup, TwitchCon 2018 to 2019, PUBG PGI 2018, and Team Flight Tactics World Championship 2018 to 2020, and many more. Thank you, Phil, for being with us here tonight. Sorry, your last one on the agenda, but exciting.
No worries. Happy to be here. Thank you for the introduction. I'm going to get my screen sharing here, and we will get off to the races. So yeah, welcome to the esports discussion. In keeping with kind of esports and the way that the industry developed and where we are, this is going to be a little bit informal. Hopefully it'll be fun. And hopefully I can kind of inspire some of the passion in our listeners that I feel towards esports, and many people in the esports industry feel, because it is an industry really built on passion. And most people that are in the esports industry are there because they love gaming, they love innovating, and they love building tools and workflows to really tell stories within that space. So we're going to get going here with a little just kind of a basic definition, right? What is esports? So to define it pretty holistically here, esports is the industry and ecosystem behind competitive video game competitions. This includes players, fans, and the production, as well as the revenue gained from the tournaments and involvement with the competitive gaming. So basically what this means is esports is not just the production. It's not just the players. It's not just the games. It is the entire ecosystem around it. And I think that's one of the really compelling aspects of it, is how you build revenue models around that, and how you figure out how you can monetize it, as well as the part that the game developers play in esports, right? Because I always liken it to no one owns the game of football, right? Internationally, you can go buy yourself a football, you can find a field or a back alley somewhere with your friends, you can go play football, no worries. Somebody owns the game of Fortnite, and somebody owns the game of League of Legends. So people actually own these sports and control them. And those sports or esports are constantly changing as the game develops, which is also another interesting aspect of it. But just kind of after we define it here, let's take a look at what it really is. What makes it special? So now I'm going to roll this video for you, and Oops, that's not what I wanted to do. My apologies.
I see the place where I was born. I was raised by the new dawn, and now I sit inside the storm. Like the eye of the pyramid, I know everything ahead. I'm in the hunt, don't you forget. Gotta work for it, every day work for it. Gotta work for it, every day work for it. Bonjour Paris!
In trouble. David's ticking down. Cap's now gonna have to run for his life. Miasma comes in. The flash over the wall. Amazing patience. Oh, what a dodge! Comes out. One more rocket, baby.
Max Loy's looking for a target. Power Wheel's waiting in the wings. Command Protect can get used as the culling.
Oh, nice
It's a
hook.
good channel. Ignor doesn't follow it over, but the engage from G2. They've jumped all the way in. The target is Unsama. Shockwave catches two. Keeps Unsama alive. Ignor's already down. Maxwell's on the back end, trying to be a distraction, but they can't burn through the tanks. Bert flashes over the wall.
Gotta work for it, every day work for it. Gotta work for it, every day work for it.
Clear who's looking to clean this up. Fnatic need to keep the members alive. Reckless! The flash forward, the broad to body block. Fnatic destroying KO.
Reckless gets the turnaround, the triple kill for Fnatic. Let's choose survivor. I keep
The culling is available. Perks can decide to chase. Dashes over the wall. Flash away from Maxwell. Flash is still available for Perks. First blood is available. Flashes. There we go. Piercing light. G2 Esports are on the verge of winning yet another final. There is nothing standing in their way. The undisputed best team in Europe, G2 Esports, get themselves another kill. And for the first time in history, the fourth consecutive EU LCS title. G2 Esports are the best team in Europe.
All right. So I don't know about you all, but I've got goosebumps after that. I love showing that video because I think it really sums up what esports is all about. You've got a stadium filled with people. All those people are there united by the love of the game, to experience competition at its highest level, and to bond with each other and connect with each other. It's that human connection that really kind of makes esports, in my eyes, special, and also regular sports for that matter, right? That connective tissue that kind of binds us all in the competitive space. That was from the League of Legends European Finals in 2019. So that was leading up to Worlds. And I just thought that video was really exciting. It shows how grand the scale can be. It shows how big the stage can be, how many fans can show up, and how much passion there is out there. Now, to many, if you're not a gamer, if you've never played League of Legends, a lot of those clips might have just looked like flashing balls of light and no idea what's going on. But I think that's also one of the interesting aspects of esports, is how nuanced and detailed each game is. And the people that are fans of specific games, they oftentimes, in most cases, play those games and understand how difficult those games can be and how difficult it can be to play at the pro level. And so League of Legends, for example, I'm horrible at League of Legends. I love the game from an esports competitive standpoint. I love watching it. I love the lore of it. But for me personally, mechanically speaking, when I watch these pros, I can't do what they're doing. They're doing amazing things with the keyboards and mice. But I just wanted to kind of start things off with a bang there, and get everyone a little bit of excited about what we're going to be talking about as we delve into the world of esports today. And
I was just going to say, yeah, speaking of start off with the bang, there is a question already for you.
Oh, great.
It says, it's interesting that organizations like TSM are worth about the same as a small football team. Do you see esports becoming as big as something like the Super Bowl? Do you see one game in particular being the dominant one?
Yeah, so I think we're already kind of there in some capacities. League of Legends, for example, Worlds, they have a world championship every year, which is obviously worldwide, and that brings in millions and millions of viewers and constantly sets records for the number of viewers and the number of attendees. They completely fill out a stadium the same way the Super Bowl would. I think that in terms of organizations, right? The question was brought up about the different esports teams and orgs. I think the teams and orgs have a really tough road to monetization, right? I think, similar to what I mentioned earlier about how the games are owned by specific companies, what you have there is you kind of have, as an organization, you have to then pander and you have to carve your way within the industry while still falling underneath the actual game owners. And what we see is different organizations kind of tackling that in different ways. So for example, you'll take an organization like 100 Thieves, 100 Thieves, FaZe Clan, mainly 100 Thieves, but they have kind of position themselves as a lifestyle brand, right? So they release merchandise, these designer hoodies and designer clothes. They do limited releases similar to the sneaker industry, and in doing so, they're building up all of their content to be this lifestyle brand, make a lot of money off merchandise, as well as influencing with views online and influence with different social media platforms. Whereas you take a team like G2 here, and they are very focused on being competitive gamers first. So they are positioning themselves as a brand that builds winners and wins championships, and then in doing so, that's kind of what their brand stands on, right? That's what they define themselves as, and then that kind of defines also where they're going to try to find their return on their investment, where they're going to try to find their different revenue. So I think it's a complicated question because the ecosystem has so many different parts to it, and we're still seeing a lot of debate out there about whether a league structure is better, similar to a lot of sports teams like the NFL or MLB, or you name it. And then we're also seeing a lot of people that are arguing for an open system, an open qualifier system, where you don't have the leagues and the teams buying slots for seasons, but instead you have what the Fortnite World Cup did, which was, they basically opened up the entire tournament to 50 million people that were playing the game. And they said, any of you out there, if you're good enough to play, and if you're good enough to play at this level, you can make it to the Fortnite World Cup. Now that kind of, in my opinion, Fortnite shot themselves in the foot on an esports front with that. What they did was they opened up a new world to gamers, where now there are kids all over the world that are trying to become professional gamers, and it seems a lot more attainable than maybe it used to be because of the open qualifier system, because all they have to do is be good enough and be able to play the game. And if they can do that, then in theory, they can make it to the top. That being said, it's not great for storylines, because what we've seen with Fortnite is that basically every new season, the best players tend to be some of the younger players, because their reflexes are very fast. They tend to not have fear or anxiety for losing yet. They haven't really gained that yet. And so what you have is you have a very high turnover of the player base, and therefore storylines are hard to follow. You don't really get to build a lot of villain and these kind of different rivalry storylines, which we see in other esports like League of Legends, and like we see rivalries in traditional sports, which are are oftentimes localized around regions and different leagues within the overall arching league, and things like that. And now I'd like to just kind of move on to let's look at some. I don't have many numbers today in terms of statistics. There are esports numbers out there, but some of them are kind of hard to sift through. And not all of them I find to be that compelling, but this is just kind of a growth of the gamers in the world, right? And so we've just seen this steady growth of billions and billions of gamers just rushing to it. And what we've seen recently in the last few years has really been a catalyst for the growth is mobile gaming. Now we've kind of lifted the barrier that used to exist in terms of being a gamer, where you had to be able to have enough money to, buy a Nintendo or an Xbox, or you had to have a strong internet connection, or if you wanted to play StarCraft at a high level in the early days of gaming, you would need to have a computer that could run StarCraft, as well as an internet connection to connect to the online platforms. Well, we didn't see that all over the world. The internet was not as attainable and widespread as it now is. Well, now we're seeing gamers blowing up in rural parts of the world. India is a great example where we're seeing the player base in India, because of PUBG Mobile, just skyrocketing. And originally you would think, oh, well, gamers, that'll probably kind of be more in the city, the more urban areas. No, we're seeing it in the rural areas, because now we have Wi-Fi everywhere. And most people, well, not most people, that's definitely, that's an overstatement, but a lot of people in the world now have smartphones. And so they're able to play games, they're able to compete just with a Wi-Fi connection and smartphones. So we're really seeing the industry change. We're seeing, especially globally, North America and Europe tend to still kind of favor the PC gaming or console gaming, but mobile is growing in those areas too. Where we're really seeing the growth though is in Asia, in the Middle East as well, and we're just seeing a huge spike in mobile gaming, and that's changing how the industry is viewed. That's changing a lot of the kind of the production elements, right? Because some of those mobile games are portrait mode. They're played portrait mode. So now you're trying to figure out how to take traditional broadcast elements that were 16:9 aspect ratio, like the screen you're looking at now, and you're trying to figure out how to place a portrait mode image in there. So I'm going to move on though, because I don't want to keep people too late here. So, where did it all begin, right? We kind of know where we are now in terms of video games, but it all began with the most basic and simple game at the time, Pong, right? And it blew people's minds. I remember my dad talking to me about the first time he played Pong, and he just couldn't believe it. And in case you're not familiar with Pong, it's literally 2 paddles and a ball. And the goal is you move your paddle up and down, and you move it so that the dot hits it. And then if it goes past you and you miss it, then the other person scores. So we start seeing cabinet games, and that's really kind of that birth of video games. People going to the arcades, them taking all their hard-earned quarters that they got for allowance, and going to the arcade, trying to get the high score on that machine and playing it, with all their friends. And that's kind of where that begins. Well, then we have this amazing moment with Atari where all of a sudden video games come home. And with TV and the developments that are happening with televisions, you now have gaming consoles at home, and the players don't have to go spend quarters at the arcade anymore. They can just sit in front of their televisions and invite their friends or play with their siblings. And then it continues to develop from there, right? I definitely don't have every single console here. There have been so many, but I'm just kind of hitting on the highlight ones. N64, that one's near and dear to my heart. Same with Game Boy. Game Boy is one of those early ones where it becomes mobile, right? This is kind of one of the first types of mobile gaming that we see, where I remember I had my Game Boy, and on road trips, I would just be playing Tetris nonstop, trying to set my high scores. And it was great when we would, take long road trips, and it just kind of enabled you to take gaming on the road, take it to a friend's house. I would take Pokemon over to my friend's house. We both played Pokemon, and we'd even trade Pokemon through the rudimentary trading system that the Game Boy had. And then it continues to develop and get more and more sophisticated, more and more featureful. We see PlayStation coming. And then in the early days of PlayStation, there's a built-in disc and that's how I watched my DVDs. And then now we've seen it develop even past discs, where it's kind of more difficult to find. You have to pay more now to have a disc slot, because everything is now connected with the internet, and the hard discs are becoming kind of obsolete in many ways. And now that we have streaming come into it, now your PlayStation or your Xbox, it's not only your gaming device, it is also your streaming device in terms.
Phil, just so you know, you've frozen and your audio is
At the
breaking
higher
up.
level.
Not sure if you're hearing
Okay.
me.
I hear you. Can you? Am I back? Did I catch back?
Your presentation's moving forward. You're frozen.
Okay, I'm gonna kill my camera.
You might want, yeah.
Yeah, I'm gonna kill my camera and just kind of relieve the bandwidth there. Pardon me. Oh, I think still hear me.
We still hear you. Oh, we did hear you.
Okay. Yeah, I think my Zoom is crashing on me. I think I'm gonna have to close it out and come back in. My apologies.
No problem. We'll see you in 30 seconds.
See you then.
Any questions for Phil in the meantime? If you want to type them in there, we can ask him when he comes back. And I think Phil forgot to stop his share, so we will. Oh, thank you. There we go.
Okay, can you all hear me now?
We're hearing you.
Check.
Yeah. Do you want to start up your presentation again?
Yes, sir. It's coming right back. My apologies, everyone.
Thank you. No problem.
Oh.
Phil is coming to you from from sunny California.
Yep, the sun has set here. So
Yeah, Rick, we should hold the questions until the end, because
Okay.
it's just just prolongs the presentations.
Yeah, I just thought some people would type some in
Yeah.
while Phil was out. Anyway, thank you, Phil. You're back.
all right, cool. I'm going to speed up my talking as well, which I can go very fast. So then we see, now PCs are kind of becoming a huge part of not only gaming, but then streaming your game and getting your perspective out there and becoming part of the streaming community on Twitch, YouTube, Facebook. And then, of course, we have the immersion of mobile, right? And so we've got all these kind of progression of different games. So where did esports begin then, right? What's the birth of esports? Well, the birth of esports, actually, it was November 1st, 1980. And it was the very first esports event. It was for a game that was called Space Invaders, which is a really fun, game where you basically are a little ship and you shoot these aliens as they come by you. And you can see here that the tournament had 10,000 participants, and it was extremely important for the growth of esports. This was televised, and it was kind of a big deal. And it was kind of the first of its kind. You can see all these black and white photos. I think they're absolutely fantastic. So as we move on, that's the birth. That's where it really technically began. So we go from the beginning of esports here, right, to something that looks pretty similar and is a very key pivotal development of esports, which is what are called LAN parties. This is something that some of you may have done, but back before online gaming was as accessible as it is now, you would literally get your friends together in a basement or a back room somewhere. You would plug a bunch of machines together, duct tape things together, and you would create a LAN party environment. And in many ways, this is, in my eyes, kind of the birth of modern day esports, not only based off of just how the industry developed, but also the people that are in the industry today. Many of the industry vets, they began in this environment. They began in those early days of esports where they knew they wanted to do esports. They just didn't know how to do it yet. They didn't have the money to bring in professional broadcast equipment. So a lot of the early esports events, in the 90s and early 2000s, they were events that were literally what you see here, just not in a basement somewhere, but in a conference room at a hotel where they would rent out the conference room and duct tape some machines together and make them work. And it wasn't elegant, it wasn't super featureful, but the important thing was that the gamers were able to come, they were able to play, and they were able to connect with each other as a community. So then we go from that to all of a sudden now money is involved. Now we start seeing bigger prize pools. So this was back in 2005. fatality, Jonathan Wendell, he won $150,000 for this tournament. And that was part of the MLG Gaming, where they basically had a tour that was televised, where they took the esports tournaments on a tour, and that was a big pivotal stepping stone in terms of legitimizing esports, but also making sure that there was a reason to compete, because that's a pretty big chunk of change, especially back in 2005. And then when you compare that to modern day, right, like the Fortnite World Cup, where you've got Bugha, who's a 16-year-old who won $3 million in one day. And we're seeing prize pools rising even above that. Now, all of a sudden you have big change behind it. You have big buy-in. You have a lot of eyeballs coming to it. And the industry has now been legitimized. And then with that, we've transitioned from this LAN party basement environment to integrating high-end production equipment, right? And what has kind of happened is this cross between high-end production equipment and then gaming equipment. So you're seeing the industry being built on a mixture of high-end production equipment that's been used for years in sports, and then figuring out how to connect that to the game and how to utilize those tools, which are very powerful in the gaming space, and utilize those to be able to actually have a compelling story told in the live environment that's true to esports. So this is kind of a little breakdown of where we're at now, right? And this is interesting when you compare it to other types of broadcasts. So in a broadcast, you've got your director, your producer, and they're the showrunners. Well, in esports, there's oftentimes, for bigger shows, there's a division, and you'll have two control rooms. Sometimes they differ in size, but you'll have this partition. And what that partition really serves is you have your primary control room, which is focused for all of the non-in-game related parts of the show. So that's the opening sequence, the talent, when the host comes on set and they're blowing mist and doing all these kind of elements of the show that are not actual gameplay. And we've leveraged a lot of very talented broadcast directors for that portion of the show. What we found though early on, and this is actually where I got my start in the industry, or in the esports industry, we found that those directors, as great as they are at directing shows and just understanding broadcast and live production, they were missing the elements of understanding the specific game they were covering. Because I mentioned earlier, each esport is so nuanced, each game is so different. You really have to understand how the game is played. You have to understand what the fans want, and you have to understand what's happening in real time to make those decisions so you can capture those stories. Otherwise, they're lost. And so we saw a lot of really great Emmy-winning broadcast directors come into esports and have no idea what they were doing. Why? Because they did not know the game. They may have directed the Super Bowl, but they had no idea what was going on in the game of League of Legends or Fortnite. So this partition was created, and now you have the observer room. So observers are virtual camera operators in esports. And what this really comes down to is, because the game is built on an engine, right? You have these virtual cameras which can fly around and can move in the actual game itself and can be controlled with the mouse and keyboard. They can be controlled with controllers. The Fortnite World Cup, we would use Xbox Elite controllers, and we'd program all the different paddles to be different, different adjustments for the cameras in the game. And so now you're taking these gamers and you're figuring out how to use virtual cameras to capture the story inside the game, which can be very difficult. Because if you take a game like football and you have your normal size pitch, even an NFL game has 60, sometimes 100 cameras just to cover that small field. Well, you take a game like Fortnite or Warzone or Apex Legends, all of a sudden you have a real sized island that is physically an island, and you have to figure out how to cover the stories that are happening. And you have to figure out how to do that with these virtual camera operators. So a lot of organization and a lot of workflow development goes into how you actually do that in a live environment. And then finally, you have the actual arena. You have the different screens and the different graphics that create either the in-venue audience experience, or if it's a studio, create the fan experience for what they're witnessing happening in the studio. So this is just kind of a nice breakdown of the difference in a lot of ways between esports and sports, is you have that partition and you have the observer room and the virtual camera operators. And now I just kind of want to take that and break down an esports image for you here. So this is an image from this is Clash Royale Worlds 2019, I believe. And what we see here is there's a lot going on, right? This is a perfect example of a game that is portrait. You play the game with your phone vertical. You can see that in the center there, but now I'm going to do a little breakdown for you. And we're going to break down really quickly all the different elements that go in this one frame. So if we go to this next page, right, we've got, first and foremost, we've got physical cameras. So we've got those face cameras there that are showing the actual competitors, making sure that the viewers are connected to them, making sure that we understand the gameplay we're watching and who the person is behind that gameplay. That really builds that emotional connection, and then therefore builds the victory, being more victorious, or when they lose, it breaks our hearts. Then you take the live camera and you mix it with a live gameplay capture, right? Or an observer. So not all games have robust observer tools where you can fly around. Some games, you're literally just taking a screen capture out of a computer or a console, or in this case, you're taking a capture out of a mobile device, and then you're connecting that in the broadcast space. And then finally, the final element that creates this whole composition are graphics, right? You need broadcast graphics to supplement. And if you notice, this I think is a great example because everything blends really seamlessly together. So how the graphics are designed, it needs to really blend with the actual tournament, blend with the game itself, and build this cohesive look where if you looked at this, you wouldn't necessarily immediately start picking apart all of the different pieces. It looks like it blends together. And then just to highlight the stats on the right side there, that's a really big part of esports, is real-time data-driven stats. A lot of games out there, they actually have APIs that will output different statistics. So whether a player gets, a certain number of kills or dies, or, it'll actually output those statistics. And then with different graphics engines, you can receive that API, and then you can have real-time updating data-driven graphics to inform the viewers as to what's going on in the game, as well as give a lot of insight as to the details behind it. So I just thought that was kind of a cool way to break down esports in general. And then as we look at it, this is a little bit more the broadcast workflow. But you're looking at all these different devices working together to create this production. That's cameras, you've got your graphics systems, you've got your replay system if you want to do an instant replay or play back a package of a player that did really well. You have your observer feeds. You have whether they're observers or whether they're game capture feeds. You need to get the game into the production somehow. And then you've of course got audio and comms, which audio on esports is one of the biggest and most difficult things to work with, because you're taking game audio, but then also oftentimes you want to have player comms because the players are on comm headsets talking to each other, strategizing about what they're doing in the game. So you need the ability to strip that audio out when you don't want it. You need the ability to include it when you do want it. And then of course you need the comms for the crew to be able to communicate so that they can nail all their cues and have a successful live show where they execute in the live production space, which of course is very difficult to do. And then, of course, we've got signal processing and routing, and a way to get all those feeds together and redistribute them and create the actual network, right, of all the different machines that are communicating. We've got our switcher, which is also known as a vision mixer in Europe. And that's what basically builds the show, right? That's where you can, that's how you create that look that I showed you, where you have live camera sources, the video game and graphics all combined, all perfectly lined up. The switcher is what does that. The switcher is also what cuts between different cameras and integrates different show elements. And then now, of course, you have LED control and different venue control elements, where not only are you thinking about what's outputting on the broadcast, you're also thinking of what's being fed to the screens for the audience, or in a studio, what's being fed to the screens and the different parts of the set to make the show super exciting. So it's a very complex workflow. And here's just I'm not going to break down this specifically, but I took all those things from the last slide. And this is a signal diagram from my company. So these are our products. that you can see, and you can see how on the far left there you have the game and the observers as well as the cameras, and then you can see the path that everything takes. And similar to the fascinating discussion earlier about IP connectivity, that's a huge part of this as well, is making sure that all those devices are connected on a network. Now, although this workflow does show a traditional signal path in terms of linear signals, it also does show the network switch there. And when you're able to connect more than one device on the same network, you're able to basically customize your workflow a lot more. And that's where we get into something that my company has a very powerful system for, and there are other companies out there. Ours is called Dashboard specifically, but the reason I wanted to show this is this idea of venue control and unified venue control. This is really big in esports because a lot of times you don't have, like I mentioned with the observers, you don't have these professional directors that have been directing or technical directing for years and operating broadcast equipment. You're taking these gamers sometimes who are really good at the game and really understand the ecosystem and understand what they need to do. And with a program like Dashboard, as long as those devices are connected on a network, you can build a customized workflow with a Stream Deck, with a touch screen, with just a UI on your computer. And you could have one operator who could trigger graphics, who could cut between different cameras, and also could trigger a replay, all with one push of a button, as well as firing off cannons or confetti, or whatever it might be. So you're able to actually unify and combine roles, which makes the process of live production more scalable, more flexible. It makes the ability to build these custom workflows, more attainable. And so we're seeing a lot of venues and arenas that are being built. They are looking for that ability to compress and combine all the elements because they are thinking of how they're going to keep their lights on. They're thinking about how they're going to keep crewing all these shows. And if every single show, like let's take an arena that they're trying to do 5 shows a week, if every single one of those shows needs a 20-person crew, that budget is going to be huge. So they're figuring out for some of those shows, we need to scale down and have a smaller crew that can consolidate the different roles and can still put on a show that's maybe not as complex as other shows that take larger crews to do. So that's kind of an exciting thing. But then beyond that, I think this is really the bigger trend, right? The bigger trend that we're seeing is all in one. We're seeing all of those pieces of production equipment being put into one system. So you've got on the top left there, that's called a graphite. That's our all-in-one system. The bottom left, you've got live stream. That's an all-in-one system. You can take in that bag. It fits in the under the seat in front of you. And then you've got vMix, which currently is the most popular software switcher in the industry and is used in numerous capacities. And it is all of that production functionality that is then put into one system. So what we're seeing is these systems are becoming better. So you might ask yourselves, okay, well, why aren't all productions run with an all-in-one production system? Well, the reason is that the old production equipment and having each piece be separated, it does still have its power in terms of reliability. Oftentimes, you can have one system fail, and then the whole show doesn't go down, right? If you're using an all-in-one, if it fails, then everything fails. The whole show goes down. Also, we're still seeing a lot of bugs being worked out. We're still seeing a lot of performance issues being figured out, where with the industry-grade broadcast and production equipment, you don't have a lot of those because they were built to be used in productions and they've been battle tested, and they're very robust and very powerful. So we're still waiting to kind of see what that all-in-one trajectory and path is going to look like as the industry develops. But that being said, it's definitely something to watch. And if you guys are interested, you can get a free trial of vMix yourselves. You can, mess around with it and you can figure out how to cut your own show. Obviously OBS is a free software that you can stream and you can make a pretty cool production on Twitch for free with that. And of course, I prefer the more robust, high quality equipment because I use it at the highest production level where there's a lot of investment going into it. So you can't have systems that fail, and you need increased functionality because you're being pushed to innovate beyond what is possible with the cheaper or the free systems. But that's, I think, one of the bigger trends that we're seeing is these all-in-one production systems and software-based systems where people can build their own computer, and they can build, a supercomputer that could be used for a production, as opposed to needing to have a rack or multiple racks to put different pieces of hardware into. And yeah, that's it. So I definitely sped up and talked quickly there. I'd love to answer any questions there might have, but also I understand that we've gone way over time. So I hope that was interesting for y'all. Feel free to find me and add me on LinkedIn. I'm always down to connect and always down to answer questions about esports or other production workflows as needed. So thank you so much.
Thanks so much, Phil. Oh, did we leave you? Oh no, just your presentation. Thanks again so much, Phil. We do actually have a question. Now we are entering, I don't know, Tony, we are entering the question and answer period, but I do have a question. I do have a question for you right away from one person. Just a bold shot in the dark, but does your company, Phil, organization offer any internships to work on esports productions?
So me, not specifically. I'm actually, so Ross Video, we're a large broadcast and live production tech company. So we make products that service all parts of the industry, from sports stadiums to live broadcasts all over the world. I am the esports representative for Ross. So I am the one who is focused on making sure that our systems are built for esports. That being said, though, hit me up on LinkedIn, and I can definitely connect you with somebody that would have a potential internship opportunity through some of the previous esports production companies I've worked through. So I'd be happy to connect you with people that I know.
Thank you, Phil. So at this point, are there any other questions from any of the students or other SMPTE members that are attending tonight? Obviously, some wonderful topics that we've covered quite a varied range, and so now it's your turn to sort of pose some questions if you have any, folks. Anything?
Well, it's interesting, Richard, while everybody's thinking about their question, this is a complete circle as to what Troy had talked about earlier in our presentation this evening about how this organization allows you to connect to people. And Phil just, hit the nail on the head. Here's a contact person that you can reach out to, and he knows somebody who knows somebody that can get the answers that you want, or even opportunities. So for me, I took this seriously when I was younger and getting started in this industry. So I urge you to take this organization and these opportunities seriously and run with it, because if you don't run with it, somebody else will. And yeah.
Yeah, by that one student asking the question, I'm sure it's in the mind of many others. And as well as any of the sort of topics that have been covered today, I'm sure that
so true.
that students sort of are delving into these areas. I know my technical production students, we've been talking about a number of these sort of areas of media and media production and archiving and IP and AI, and these are all topics that come up in our discussions. So this is a place to learn, and if you're not learning from our esteemed guests here with us today, you can certainly be learning from being a member of SMPTE and meeting up with some of the people, hopefully in person someday soon. We hope in the next month or two that activities will start back to in person. So, and with any of the in-person meetings that we have, just so students know, there's usually an hour's opportunity before our meetings to sort of meet and greet with the guests and the other SMPTE members and other participants, So it is a wonderful opportunity to really engage and learn.
And yeah, Rick, I posted my LinkedIn link there in the chat. If anybody wants to add me, I'm not very choosy with my LinkedIn ads, so I'd be happy to connect with anybody that wants to know.
Thanks so much, Phil. So any questions from anybody else, or even any of the panelists, if you have some additional items or you want to ask some questions of some of the other panelists? No? If not, Tony, I don't know.
I'm going to move it forward. Yeah.
Yeah,
So,
I was just going to say.
Yeah, you know what, I think all of our SMPTE members and not board members here especially, and the organizers of this meeting tonight really thank all of the presenters for spending some quality time with us and the students and our membership base. It's really, really appreciated. Just a couple of quick things, and Brian, if you're still online, yes, you did steal my thunder, but that's okay. You're allowed to do that. So tomorrow you're going to receive an email from Zoom if all people that have registered. That's a normal thing that happens through the Zoom webinar portal. But we're adding a survey component to this. And there is a prize giveaway, like Brian mentioned. There are 5 books, of which 3 will be allocated for students that fill out the survey, because there is a special section for students. And there's 2 books available.
Brian is displaying it.
Oh, Brian. Yeah, you have to speak, Brian.
Oh, he's just displaying the book, that's all.
No, but we can't see him while he's not talking.
Oh, I see.
Visuals. All right, everyone. Sorry, Tony.
There you go. Perfect. So, yeah, so Brian co-authored with Chris and Clyde. So to be considered, we do need your first name, last name, and email address, and you need to complete the whole survey. And we're going to let it run for 7 days, and by March the 1st, we should be able to reach out to the winners. I think we are going to have the books signed, if I'm not mistaken, Brian, because we'll know by then who the winners are, and we'll feed that to you, and we will reach out to you, find out your contact information, and then ship the books to you. Does that all make sense? As well, there's a recording tonight, which one question I forgot to ask, but I will reach out to all the presenters. Sometimes our presenters don't want to be included in the recording, so we'll make sure we get that all figured out and then present the recording to our YouTube channel, and you will get the same email you get tomorrow. We'll also have the link to the YouTube channel, but we will require some time to just clean up some of the heads and tails of the show, which usually takes a week or so to do. Our March meeting, again, we do this every month, 10 times a year. July and August, we have vacation time. March the 8th is, we're looking at virtual productions. April the 12th, we're looking at SMPTE Standards update. May the 10th is an NAB wrap-up. So that's the National Association of Broadcast Convention that happens in Las Vegas. And June the 14th, we're still trying to figure that one out. And we're hoping that that might be our first face-to-face. So keep our fingers crossed for that. On the SMPTE side, for members, we are about to get into another election every March, April, May timeframe. Once a year, we do have an election process that we look for new board members to help us move this forward. We can't all do this by ourselves, and we want to make sure that we give everybody an opportunity to join the board and we're always open for new ideas, new blood, things of that nature. So we've already reached out to a few people and got our roster ready for this year. But if you're ever interested in wanting to participate, do let us know. You can reach out to us at the various connection points, whether it be email, Facebook, Twitter. And if you're not a member, you can become a friend, which at that URL, and that allows you to get all of our email blasts that announce what meetings we have, when, and how to sign up and become part of the meeting. So again, it's something that you should subscribe to if you're not a member of SMPTE yet, but at least it gets your toe in the door. Anyway, that's it. It is way past people's bedtime, depending on where you are. But thank you for sticking with us for the 2.5 hours that we've been at this, and it's been really good information, and we thank everybody. So again, be safe, be well, and that's a wrap. So thanks very much, everybody, and we'll talk later.